Okay, so it says, right, you know the Kf for the silver ammonia complex. That's 1.7 times 10 to 7, very large. And we also know the Ksp for the silver iodide. That is about 8.5 times 10 to minus 17, which is very tiny. So now we want to know, right, when you dissolve the silver iodide into the ammonia solution, what is the solubility? So if we express uh, the process, right, with chemical equation, that is actually initially you have the silver iodide, and then, right, you dissolve that into the ammonia in the aqueous state. Then you generate the silver ammonia 2 plus and the I minus iodide ions, right? So for this one, right, so it tells you right here the concentration of the ammonia is given in the equilibrium state, right? When you have about 2 moles of the. So initially, right, you have so this one, right, we need to use this one anyway to calculate the solubility. So that means we actually need the K, right, the equilibrium constant of this question of these reactions. How can we get the equilibrium constant for this reaction? We can utilize the information given by the question. So first it says, right, the Kf of the silver ammonia. So if we express that, right, it's the silver plus in the aqueous solution and reacts with true ammonia and forms the silver ammonia complex in the aqueous state. And this is a Kf. So let's say this is equation 1. And equation 2 is a dissolving of the silver iodide. It dissolves into silver ions. And then the iodide ions. And of course, it gives a Ksp, which is a tiny number as we have mentioned here. So by observing, right, you can find if you want to generate, let's say this equation 3. This equation 3, right, actually equals to what? Equals to equation 1 plus the equation 2. So it tells you equation 3 equals to equation 1 plus equation 2. So that means for the k value, right, for the equation 3 actually equals to the k1 times the k2. So the k1 is a kf, and the k2 is a ksp. So that's equal to 1.7 times 10 to 7 times 10 to minus 17. So in this case, it's about 1.7 times 10 to minus 10. So in this case, we can start looking at this one. So now let's just simply copy and paste the equation again. The silver iodide react with true ammonia and produce the silver ammonium 2 plus, and iodide ions. So to calculate the solubility in the equilibrium state, we need to draw the ice table. So initially, we leave the solid here. It says initially you have the 2 moles of the solution, right? Ammonia solution. And you don't have any ammonia complex. You don't have any silver minus here. And then upon the change, right? Let's say 2x moles of the ammonia will be consumed. So it's 2 minus x, minus 2x, right? And silver here will be x generated, and x moles of iodide be generated. So in the end, you have, so just minus 2x for the change. So in the end, the concentration would be 2 minus 2x for the ammonia. And for the silver ammonium complex, it would be X. For the iodide, that will also be X. So in this case, the K for this reaction, right, the K3 equals to the concentration of the silver ammonia complex times the concentration of the iodide over the concentration of the ammonia here, power 2, because the coefficient is 2. So that's x squared over 2 minus 2x squared. That's equal to 1.7 times 10 to minus 10. So let's do the calculations here. So that means x over 2 minus x equals to 1.304 times 10 to minus 5. So the x here will be equal to 2.608 times 10 to minus 5 minus 2.608 times 10 to minus 5x. So that's, if you do the calculations here, it becomes 1.00002608x equals to 2.608 times 10 to minus 5. And that's equal to the x will be still equal to 2.608 times 10 to minus 5 more. So this is the molar solubility, right, of the silver iodide in 2 moles of the ammonia. And this is the answer. That's it.